Hi everyone, it's Miss Bowen from PEP Practice. Today I'm joined by two of my students. We're going to be going through the 2023 mathematics performance task together. I hope that you're able to learn from what we are sharing. And I know you have your exams next week, Wednesday, starting next week, Wednesday. I wish everyone all the best on their exams. And as usual, you can comment or reach out to me if you're having any form of queries, and I'll see how best I can assist. All right, so let's get into the paper. So we have the general instructions here. Let's go ahead and read the scenario. It says premium packaging. Premium packaging makes cardboard boxes of different sizes. Other companies buy these cardboard boxes from premium packaging to package their own products. Premium packaging sells two types of boxes. Standard cardboard boxes. These boxes are already made. The dimension of these boxes cannot be changed. And then we have custom-made cardboard boxes. These boxes are made based on the dimension given to the company by the customer. We're seeing the box here.
I never want this.
It says Plego is a company that makes and sells toy building blocks. They want to buy cardboard boxes from premium packaging to package their building blocks. Plego wants to determine whether buying a standard cardboard box or buying a custom-made cardboard box would be better. Plego needs your help to find the number of building blocks that can fit into a standard cardboard box, determine the dimension of a custom-made cardboard box, and recommend which of the two boxes would be better to use to package the building blocks. So part one, we are seeing the standard cardboard box, and the standard cardboard box is shown below, and the faces of the box are labeled A to E. We're only going to be doing part one, and hopefully part of part two in this video. I'll do another video for the remainder after. It says the standard cardboard box has the following dimension: 10 units, 3 units, 10 units for the length, sorry, 3 units for the width, and the height is 2 units. Question one shows the net of the standard cardboard box, and we should use the dimension given to correctly label the size of the net and write the correct measurements in the spaces provided. So here we can see we can look back up at the figure that was given initially for the dimension. It says that, let me scroll back up to it. The length is 10 units, the width is 3 units, and the height is 2 units. And even from counting here, we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 units here. That's the correct labeling. We're just going to put 10 units. And for B, which is 3 units, we can also count it. And for C, it's 2 units. So that's how we would label question 1, the diagram in question 1. Are you seeing that, Shanice and Karim?
Yes.
Okay.
Yes, miss.
You understand how we got these answers?
A little bit, miss.
If you count it, Shanice, here, 1, 2, we'll see 2 units. And if we count 1, 2, 3, it's 3 units, and we already counted the top and we saw that was 10. All right? All right, let's move on to number 2. The total area is the amount of cardboard needed to make the box. Table 1 shows the length, width, and area of each face of the standard cardboard box. Complete the table by writing the missing length, width, or area of the face of the standard cardboard box. Use the net in question 1 to help you. Table 1 has the dimension of the faces of the standard cardboard box. And they gave us an example. Face A, the length is 10, the width is 3, and therefore the area is 30 because 10 multiplied by 3 is 30, and it is measured in units square. We can label up the diagram a bit clearer so we can see what is happening. So if here is 10, here is also 10 units. Are you seeing that? Because whatever the top of the rectangle is, the bottom will be too as well, right? Are we following? Here's also 10 units. If here is 3 units, for this side is also 3 units. And if here is 2 units at the top, here is also 2 units. So we can measure. And if here is 3 units, if there is 3 units, here is also 3 units. Are we seeing that? Here's also 3 units. And up here is also 2 units. And so we've labeled it, and we can start filling out our table. So I know the dimension for D. Right? We looked at D. No, we looked at A. So I know the dimension for A is 10 here, and we had 3. So 10 times 3 will give us 30 units. And that's how we got the 30 units here for the area. Are you seeing that? And if you count it up, you'll see that there are 30 boxes on the inside. All right. Let's move on to B. So we can look at the dimension for B, and we saw 3 and 2 here, right? So if we have a 3 here, all we need to do is put a 2 here. And for the area, the formula for area is length times width, and that's how they got the 30 here. So we'll multiply 3 times 2 to get 6. And if you look at the diagram, here is also the same as B is the same as C. They'll have the same dimension, 3 times 2. So we can just put in the 3 times 2 here as well. 3 times 2, and that's how they got 6. Are you seeing that? And let's look at D.
Yes, miss.
If you look at D, the dimensions of D are, here is 10, and this side, this is also 2 units. Let me just copy 2 units and place it there. Here's also 2 units. So it's 10 times 2, which is 20 for the area of D. So we'll put 10 here, times 2 gives us 20. And if we look at it, D and E has the same dimension, they're both the same. So here is also 2. And for E, here is also 10. We'll say 2 times 10 also gives us 8. And they gave us the total, the total area here. And just to make sure we can check it, so you say 30 plus 6 plus 6, that's 42. Plus 20, 62. Plus another 20, 82. Are you seeing that, Shanice? Are you looking at the screen?
Yes, miss.
Okay. All right, so it's safe for us to now move on to question 3. It says a toy building block is 1 unit long. One unit wide and 1 unit high. And we can see the dimension here. Question 3 wants to know how many of these blocks can fit into the standard cardboard box. We're seeing the dimension here for the cardboard box. 3-dimensional, so if we need to find out what is the capacity, what can hold in this box, we'll have to find the volume. All right, have you ever heard of volume? The formula for volume is the length times, I'm using the letters, length times
Yes,
width
miss.
times height. All right, so remember that's the formula for
Yes,
volume.
miss.
All right, so if we do the length times width times the height, we know that it's 10 times 3 times 2. And we know that 10 times 3 is 30 times 2. 30 times 2 is 60. And we'll put, do not write on the board. That's 60 units. Do not write on the board, erase it. Okay. All right. So there we got the volume for the standard cardboard box. Volume for our volume of so this is the volume of the standard cardboard. All right. So now we need to find out. So that's how many boxes can hold in there, right? So we need to find out, that's the capacity. How many units this box covers. So now we need to find out the area of this toy building block. Sorry, not the area, the volume. Because we need to find the volume of this toy box so we can find out how many of them will fit into the standard cardboard box. So we can say the volume of the toy building block. And it's the same thing, the same formula we're using, the length times the width times the height. Now all of this is 1, right? So the length is 1, plus the width is 1, plus the height is 1. Are we seeing that right here? And if we say 1 times 1 times 1 is still 1, right?
Yes, miss.
I left off something. It should be cube units, because the volume is measured in cube units. So that's 1 cube units. Let me just add it to the working out that I did before. Cube units, all right? Or units cube. So now we can find out how much of these toy building blocks will go into the standard cardboard box. So how are we going to find that out? We can say that the number of blocks that can fit into the standard cardboard box is whatever the volume is for this cardboard box divided by the volume for the cube. Are you seeing that, Shanice?
Yes, miss.
All right, so the number of blocks that can fit into the standard cardboard box, remember that the volume for all of the space inside of this standard cardboard box is 60, right? 60 cube units. And then remember, one of these blocks is 1 cube unit, right? So all we need to do is divide the volume of the cardboard box by the volume of the toy block. And we'll see how much toy blocks can fit in there, right? So 60 divided by 1 gives us the same 60. So we know that 60 blocks can fit there in the cardboard box. Are you seeing that, Shanice?
Yes, miss.
Okay. Are you understanding thus far?
A little bit, miss.
Okay. What are the areas that you're not quite understanding so far?
Is we supposed to plus up all of the sides or multiply?
Multiply. If you look here, it says multiply. You're multiplying the length by the width, sorry, times the height, right? So you're multiplying 10 times 3, which is 30, and then you're multiplying the 30 times 2, which is 60. Are you seeing that? But that just gives us the
Yes.
volume. It doesn't tell us how much block can fit into it as yet. We have to divide the volume for the block, and we did the same thing. We multiply the length times the width times the height. 1 times 1 times 1 will still give us 1. And then we divided that 60 from the volume here by the 1, and we got back 60. And that tells us how many blocks can hold into the standard cardboard box. All right?
Yes, miss.
Let me know. All right, let's move on to the next question. And we're moving on to part 2. Part 2 is about the custom-made cardboard box. So Playgo is thinking about ordering a custom-made box. The total area of the net is used to calculate the amount of cardboard needed to make the box. And Playgo has asked Premium Packaging to design a custom-made box that meets the following requirement. The dimension must be different from the dimension of the standard cardboard box. It must hold the same number of toy building blocks as the standard box, sorry. And the width must be more than 2 units, and the height must be 2 or 3 units. So for question 4, based on the requirements above, what are the dimensions of the custom-made box that you suggest Premium Package make for Playgo? Write the dimension on the lines provided. So if we look back at the standard box, let me scroll up, can hold 60 blocks, right? And the dimension, if you look back at the dimension, we're seeing a dimension here. It was 10 by 2 by 3. So we have to have the same thing, the same volume, but we have to have different dimensions. So we just have to try in things to see if it comes to the same dimension, but we also have to keep these requirements in mind. Right? We know that it must be different dimensions. We touched on that it must hold the same type blocks, but the width must be more than 2. So it can't be 2 or less than 2.
Oh.
And the height must be 2 or more units.
Matter of fact.
See some there, click on it.
All right, so let's look at the height. It says 2 or 3. Let's try 3. And the width must be more than 2. Right? I'm gonna try 4. That's more than 2. And now I know that I need to get 60 for the volume, right? So I thought about it and I said that if I multiply 3 times 4, that's 12. And what multiplied by 12 will give me 60. And I know that's 5. So I can use these 3 dimensions. Just let me check if these are meeting my requirements. My height must be 2 or 3. Yes, my height is 3. And my weight must be more than 2. And 4 is more than 2, right? And it didn't say any specific requirements about the length. It just said that the volume has to be the volume has to be 60, right? I'm just trying to see if this works. So my length is 3. Sorry, my length is 5, but my height is 3. So 3 times 5 times 4. It can be done anyway. And I know that 3 times 5 is 15. And 15 times 4 is 60. So I got by the same volume, all right? So that means that this box, this custom-made box, can hold the same number of blocks like the standard box. Are we following?
Yes, miss.
Yes, miss.
Okay, great. It says how much cardboard is needed to make the custom cardboard box. Like what we did for the table, that's what we need to do here. So I'm just gonna label up the box once more. If I know if here is 5 at the top, I know that this bottom part is also 5. And if the width is 4, I know that the top part here is also 4. If the height is 3, I know that all of these heights all around the corner of the box is also, or cuboid is also 3. And I know if here is 4, across here is also 4. And the top part here is 5. The bottom here is also 5. Are we seeing that?
Yes,
Yes,
miss.
miss.
So now I can be better able to work out my area, because that's what we're working on. We're working out the area for all of these faces, right? I'm going to start with A. Area of A equal, let me look back at the dimension. So it was 5 here and 4, so that's 20. That's 20 units. Area of B. Area of B. I know that it's 3 times 4, so that's 12. And I know for the area of C, it's the same because B is across from C, so it's the same as B, which is also 12. I'm not sure what happened. Let me just put in back the dimension. I said, then we have the working out. And we have the dimensions for all of the faces and the area for all of the faces here. And when we calculated the total area for the net, it was 74 square units. So that's where we end with this part of the video. So I worked out part 1 in its entirety and A and B for part 2. In the next video, I'm going to complete the remainder of the task. Try to share the video with someone who you know needs the additional help. These videos are very informative and shows detailed working out as to how we got all the answers. So I'll see you in our next video. And don't forget to like, share, and subscribe to our channel. I'll see you next time. I don't know what is happening to me today.
Bye, miss.
You're not buying. I just ended the video, but you're silly. Bye.